Hi everyone, this is Julia from the Macedon Public Library, and today Brian, our resident scientist, astrophysicist, will be talking about comets and meteors, and I believe the title of this is It Came from Outer Space. So take it away, Brian.
Hi. Hello again, everybody. Our weekly science thing. So I thought I would talk about what are mostly meteorites and comets. So in the modern day, we send things out into space to find out what they were like, but there are also a lot of things that come from outer space to Earth, and they are surprisingly common. So these, if you can see them, are bits of a rock from space. They are chunks of a meteorite that hit in Arizona a long time ago and made a crater that's now known as Barringer Crater. You can actually go out to it and see it. I think it's a park now. It used to be privately owned, and now it's a national park or a state park. But you can actually go out to Arizona and see what's known as Barringer Crater. And it is where a rock basically the size of a motorcycle or something smacked into the earth and created this little crater. It's happened a lot throughout Earth's history. Most of the craters, though, have eroded away. So you don't see craters in your everyday life. And if you look at the surface of the Earth, you don't see craters. Unlike the moon, for example, where if you look at the moon close up, you can actually see craters that are still there because the moon doesn't really have an atmosphere and it doesn't erode the surface away. Barringer Crater in Arizona happens to still be around and very clearly seen as a meteor crater because it's a dry area and it only hit, I'm going to say, about 8,000 years ago. So it's a relatively new crater, but it hasn't eroded away yet. So that's a pretty large object to hit the Earth. There have been really, really large objects that have hit the Earth, but they occurred like millions and millions of years ago. And so you can still see some. There's one in Canada that if you look at the satellite imagery, you can actually find this very huge crater that it's now the valley of a town. So you can see that type of things, but not recently. Most of the rocks that come to space are fairly small, and they tend not to make much of a crater. So if you get something, the size of your head, that's a pretty big rock most of the time. There are some things that are larger, but usually they're really rare, So while meteorites are common, it's not something that poses a large threat to humanity. One of the things is the dinosaur extinction was one of these really, really huge rocks that 65 million years ago hit the Earth and created a global winter and caused, or at least accelerated, the extinction of the dinosaurs. Which was good for us. It was bad for the dinosaurs, but it was good for us. So there is this kind of idea that rocks from space will come and obliterate a city or wipe out humanity because it makes a great movie when you have the idea of this huge asteroid coming to destroy Earth and then Bruce Willis has to save us. All of those things. But it's not very realistic. One of the things we know is that of all the rocks in space, all the meteors in space or comets in space that are capable of being large enough to really threaten humanity, like the type of rock that if it hit us, we would really be in a bad way. Those are so large that we can see them pretty easily. So we know where these rocks are, where these meteors are, and or asteroids really, but none of them are in the path of Earth. So of all the large, Earth-threatening, life-threatening rocks that might hit Earth, none of them are on collision courses. So that's not something we really have to worry about. We would have to worry a little bit about ones that are big enough to destroy a community. So in, I think, 2014, there was a large meteor that was seen in Russia. And this thing was probably about the size of a car, maybe a little bit bigger than a car, maybe like an SUV. And it happened to come into the atmosphere at a very shallow angle. So it hit the atmosphere and then exploded over Russia. And then parts of it hit the ground and made kind of a small crater. So it actually caused some injuries, because when the thing exploded, it created a shock wave and it burst windows in the area. And so a lot of people got hurt by flying glass and stuff, because they were seeing this fireball come in, and then they went to the windows, and then the shock wave hit, and people got hurt. But it didn't wipe out a town. It could have cleared several square miles if it had come steeper. So if you had a rock that size that had come steeper, it wouldn't threaten life on Earth, but if it hit Macedon, for example, that would be bad news for Macedon, you know. And those are a little hard to find. So there are programs out there, the research programs, that are trying to find rocks of kind of car size that might cross with Earth's orbit. And it's probably worth doing because, we want to be able to protect people if we can. But even though most of them, I mean, there are some that happen like every 10 years or so. There might be one that size that hits Earth. They tend to either come in shallow over the atmosphere, so they don't pose a risk, or there's a huge bunch of ocean and water everywhere. They happen to explode over an ocean or over Siberia or over lots of places where we don't live. And so the chance of them actually coming in a very populated area is pretty small. Not zero, but it's small. So that's kind of the thing of, the actual threat. It's not zero, but it's not huge. And we know that it's not huge. But there has been this history of the idea that a rock from space will come and kill people or collide with the Earth and destroy the Earth. And so that's been a thing. And that's a long tradition. Anytime you see something in the sky, that's a little intimidating. So things like meteors have been seen as kind of bad omens if you see them. Comets in particular were seen as either a bad omen or a good omen, depending on how the historian would write it. So probably the most famous one is, if you know the Battle of Agincourt, that was between the English and the French, or depending on how you talk about it, the French English and the English. But when there is a tapestry that portrays this big battle that changed the history of England, and there is a comet that is, stitched into this tapestry, and that's because around that time a comet was seen in the night sky. And this was seen as a good omen for the English king. So there is a history of that. More relevant to kind of the scientific aspect of it, we actually like getting rocks from space, because rocks from space tell us about things that are in space. So there's actually a whole program to look for rocks that have landed, somewhere on Earth so that we can study them. One of the things that we can do is we can actually look at, say, the chemical composition of the moon or Mars or specific asteroids like Vesta, and we can compare them to the chemical composition of rocks that come and hit the Earth. So meteorites that hit the Earth, we can study the chemical composition of them and compare them to the chemical composition of things that are out there. What's nice about that is that it kind of allows us to study things that we couldn't study otherwise. So as kind of a really good example, we have sent probes to Mars. We have sent lots of probes to Mars, but we've only covered a very tiny area of Mars. We don't know if there's life on Mars. We don't know, some of the things about its history. We're still trying to figure that out. And that's because it takes a huge effort of a satellite in order to go to Mars and actually land there. But sometimes a big meteorite will hit Mars and it will throw so much debris so high that some of that debris will actually escape. So chunks of Mars will escape the gravity of Mars and they'll orbit the sun and eventually come to Earth. So we actually have chunks of Mars that have landed on Earth as meteorites. And so there are these things that are Martian meteorites. And I'm one of the fortunate people who, if you can see that, that is a chunk of a meteorite that landed in North Africa that we now know from the chemical identification came from Mars. The reason that's really useful is that we haven't brought rocks back from Mars. All we've done is analyze things on Mars and tried to figure them out. But because we have Martian meteorites, because we have meteorites from Mars, we can actually study not just the composition, but also how Mars has changed over time. There have even been studies that have looked for whether or not there are fossils of microorganisms in Martian meteorites. And there are some that have said, yeah, we think we have some evidence, and the vast majority of scientists say, yeah, probably not. But it's an interesting idea of how, because the rocks come here, we can actually study them without going into space, because they actually do that. That's probably one of the big ones. And it's a little bit more relevant for kind of the near term. By looking at some meteorites, we can also identify them with certain asteroids. And that means we can tell what composition the asteroids have. And this is one of those things that people like Elon Musk are really excited about, because if we know that there are particular elements out in an asteroid, then we could actually, go out there and mine them and get all of the stuff that we want to get. One of the things about our modern world is that a lot of the computers and cell phones and televisions and all of the stuff that we use in our modern everyday life, a lot of them use types of elements that are called rare earth elements. They have very nice properties for electronics, and the reason they're called rare earth elements is because, unlike iron or gold or silver or things like that, you don't find them in nice veins of metal that go through the earth. So if you're looking for something even rare like gold, you can find an area where there is gold, and you're going to mine in that whole area. You'll find veins of gold ore that you can actually get stuff out of. Rare earth elements are very heavy elements. And so all of the rare earth elements that formed with the Earth actually just went into the core because they're heavy enough that they sank before the Earth cooled. So the rare earth elements we actually get here came from meteorites. So meteorites that had rare earth elements smacked into the earth, and so we can get these rare earth elements. Most of the places where we mine rare earth elements are places where big meteorites hit. So that's why they're rare. They're hard to find. If you could go to space, you can go to an asteroid. You could get an asteroid that's maybe the size of your kitchen. That's only 30, 40 meters across. And you could mine that and have more rare earth elements that have ever been mined on Earth. So there are asteroids out there that if you could get to them and if you could mine them, are worth well more than $1 trillion. So one of the things that a lot of the people who want to commercialize space are talking about is, can we get to these asteroids and actually start mining them for all the good stuff that we want to have here on Earth? And we know that because of studying asteroids and meteorites that have hit Earth in the past. So we know that that's something that we want to do if we want to have lots of rare earth elements for our cool tech toys and stuff. So that's kind of a background of meteorites and comets and stuff. Probably I guess the latest kind of thing is that we're starting to see that there are meteorites and comets around other stars too. It's something you would expect, that there would be asteroids and comets orbiting other star systems, but we're actually getting to the point where we can see some of the comet material and debris material around other solar systems. So they would have them as well. And we know that some of them, there is 2 cases, one asteroid and one comet, that we know were actually not formed with our solar system. So the vast majority of asteroids and comets formed in our solar system when it was very young, and just never formed into a planet or whatever. But there are a couple that their paths going around the sun are so fast that we know that they came from another star system. And so we've identified 2 of these interstellar objects. One of them is basically an asteroid-like object. Another one was a very comet-like object. It had more water vapor and stuff. So we even know that even interstellar asteroids can visit our solar system. That's one of the things that interests me. I want to be able to identify one, and then let's send a space probe to one of them and see what they're like. But that's still down the road. If we can find another one, maybe we'll do that sometime. So that's kind of my summary of meteors and comets and meteorites. So do you have any questions on things, or?
I don't think so.
No?
No. We're good.
Okay. So yeah, that's the thing. If you're ever interested in meteorites and stuff, I am sure at some point there will be a display of them at the library. I think there was once. Steve has brought things. He collects these things. So, but yeah, there are little displays that you could do with those. Or if you really wanted to get one, I think you can get one for like $40 if you're not interested in it being pretty or something. The metal ones like this, like these are very iron-rich, metally ones. Those are relatively cheap. If this isn't pretty, it's not very big, so it's not very expensive. You can actually buy them from meteorite dealers. The ones that are expensive are ones that are rocky, so they're made more rock-like and sand-like than iron-like, and that's because they tend to degrade very quickly, and so they're much more rare. They actually hit the earth more, but they degrade very much, and you can't find them. So the metal ones are easier to find. That's the difference. And I do not have non-metallic ones at all. There are very pretty stony ones called chondrites, and if you can slice slivers of them, and they have this kind of glowing amber color in them, and they're just far too expensive for me to even think about trying to get one.
You put them on your Christmas list.
Santa would have to be very good. I don't think I'm good enough to be on that Santa list. But no, I'm really happy with my little Martian rock, which normally you wouldn't get, but a colleague of mine at RIT used to do research on them, and so he had these Martian rocks because they typically go to researchers. And the one I have is basically a chunk off of a bigger chunk that was used in experiments and science research, and then it eventually becomes so contaminated that it's not useful for anything. So I have this ugly little chunk of a rock that doesn't look like anything, but it does happen to be confirmed to be from Mars. So I like that one a lot.
Yeah, that's great.
What about, have we gotten any rocks from Venus or Mercury?
I don't believe we've gotten any from Venus or Mercury. We know we've gotten some from the Moon, from Mars, and from the asteroid belt.
Oh,
There is some debate about whether or not we have gotten rocks from what are called the Trojan asteroids. The Trojans are basically a cluster of asteroids that happen to orbit with Jupiter. So basically Jupiter kind of caught them, and they're called the Trojan asteroids. We may have gotten some from that. The reason we get things from the Moon because it's close. They're actually pretty common. But we've actually brought rocks back from the Moon, so they're in some sense less valuable. But it is easier for things out in the solar system, Mars and Jupiter and outer planets, to come inward than it would be for material from an inner planet to come outward. So Venus almost certainly has been hit by rocks from Earth, certainly from the Moon, rocks from the Moon. But going the other way around would be really hard because there's not enough energy. Basically, things like to fall towards the sun. And so if Mars gets some rocks that come off, it's easier for those rocks to come closer to the sun than it is for them to get enough energy to go really far out from the sun. So Venus, if it got hit by a meteorite, the chunks would tend to stay close to the sun. They wouldn't tend to come out that far. So as far as I know, there are no confirmed Venus or Mercury rocks.
okay.
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 Okay, thank you, Brian.
You're very welcome.
Very
Enjoyed.
interesting as always.
Yep,
Okay. Well,
See you
I will
next
try and
time.
think of something for next time.
Hope
Great.
so.
we'll look for it.
Thank you.
Okay.
Bye-bye.
Thanks. Bye-bye.
You bet.